Good afternoon, everyone. We are three. We're gonna report failure model and measurement reliability. And my group mates, Joshua Oxenia, Give up John Christian, Gin to Anderson, Solid Aiden Owen, and me, Sam, and Ryan Chum. The first present.
Failures mode and effect analysis. Next slide, please. Failure mode and effect analysis is a systematic method to evaluate and identify where and how a product or process might fail. It is a proactive approach to assess the impact of potential failures and identify the components within the process most in need of change. Failure mode refers to the manner in which failure happens. Effects refers to the undesired effect experienced by the customers, either internal and external. Basically, yung failure mode and effect analysis, isa siyang structured approach para makita yung mga potential failures na pwedeng mag-exist sa design ng isang product or sa process ng pag-create ng isang product.
Next slide, please. Second is failure mode effect and criticality analysis. Okay, next, please. Failure mode effects and criticality analysis, or FMECA, is a method which involves quantitative failure analysis. The FMECA involves creating a series of linkages between potential failures or failure modes, the impact on the mission or effects, and the causes of the failure or causes and mechanisms. Where FMEA only offers qualitative information, FMECA offers both qualitative and quantitative information, allowing users to measure a level of criticality to failure models and order them to according to importance. So basically, ito lang in-explain niya is mas flexible yung FMECA kesa sa FMEA kasi both kaya niyang qualitative and quantitative information. Thank you.
So, fault tree analysis. Next, please. So, fault tree analysis is a systematic and graphical method used for analyzing the potential causes of a system failure. It starts with the top-level event, which represents the failure that needs to be analyzed, and then systematically breaks down the causes of that event into smaller contributing factors. These factors are represented in a tree-like structure, with the top-level event at the top of the tree and the contributing factors branching out below it. Once the major causes are identified and addressed, FTA can help maintenance team prioritize corrective actions. Next slide, please. So in this sample, you could see the fault tree analysis of a pump motor assembly that had no flow. You could see that to be either a mechanical failure or an electrical failure. And below it shows the possible reasons why it had failed. So by using this kind of analysis, you could easily see what could have been the possible reasons why the pump or motor assembly had no flows.
Next is the time to fail. Time to TTF, average time failed failure system, can be calculated by taking the operational and divided by the number of system failed with period. So MTF stands for mean time to failure. It represents the average amount of time of a device or system that is expected to operate or experience failure. It is a key used in reliability engineering to assess the expected lifespan and reliability of virus components and systems.
Next is the MTBF, or mean time between failure. MTBF is a measure of the reliability of a system or component. It is a crucial element of maintenance management, representing the average time that a system or component will operate before it fades. The MTBF formula is often used in the content of industrial or electrical system maintainability, where the failure of the component can lead to significant downtime of event safety risk. But MTBF is used across any types of repairable system and diverse industries. It can help measure the overall reliability of manufacturing plants, energy grids, informational networks, and countless other use cases. MTBF is calculated by dividing the total time of operation by the number of failures that occur during that time. The result is an average value that can be used to estimate the expected service life of a system or component. For example, let's say you want to calculate the MTBF of a motor that operates for 8 hours per day, 5 days a week, for a total of 1 year. During this time, the motor fails 4 times. To calculate the MTBF is, here's the example. Total operating is 8 hours of 8 hours per day times 5 days a week times 42 weeks, total of 2080 hours. Then the number of failure it is equal to 4. The MTBF total operating time over number of failures equals to 2080 hours over 4 equals to 520 hours. The MTBF of a motor is 520 hours. This means that on average, the motor can be expected to be operated for 520 hours or 20 before it fails. In reality, it may fail much sooner or much later than 520 hours. And we won't understand why the motor is failing. But this average time is useful metric, a starting point that enables us to get a basic sense of how a system or component is performing in terms of reliability and help us to analyze trends which help us to understand the overall efficiency of our maintenance.
Next is failure rate patterns. Next slide, please. Okay. So failure rate patterns, the widely recognized bathtub curve model serves as foundational framework for understanding failure rate patterns. This model delineates a system's failure rate over in life cycle comprising three distinct phases: infant mortality, random failures, and wear out. The initial phase out, characterized by a high failure rate, represent the presence of manufacturing defects or insufficient testing. Subsequently, the system transitioned into a phase marked by a relative constant failure rate, indicative of stable operation with failures occurring randomly. So finally, as components age or degrade, the failure rate gradually escalates, culminating in the wear out phase. Okay, next slide po. Okay, so ito yung mga nire-represent or kung paano yung yung mga graphs or yung paano yung pattern sa rate sa failure rate pattern. So ito yung tinatawag nating bathtub. Pattern A is equals to 4%. So yung next sa kanya is yung wear out, which is 2%, pattern B. So next is 5% fatigue. Nakikita nyo naman, ano lang siya, parang straight lang siya. Tapos yung next is yung 7%. Parang opposite siya nung bathtub. So yung next is yung sa yung sa random tsaka infant mortality. Ito yung parang yung last. yung 14% tsaka yung 68%. So, yun lang. So, next page. So, measurements of reliability. Reliability engineering relies on various metrics to assess system performance and durability. Mean time between failures measures the average duration between consecutive failures and is particularly useful for system exhibiting a constant failure rate. Conversely, mean time to failure or MTTF estimates the average time until the first failure, making it suitable for system demonstrating decreasing failure rates, often observed in early life failure patterns. Additionally, Weibull analysis involves fitting failure data to the Weibull distribution, offering insights into failure patterns and aiding in predicting future failures. These methodologies enable reliability engineers to identify potential failures, modes, and implement appropriate preventive measures, thereby enhancing product quality. So sa measurements of reliability, parang kinonklud lang lahat. Yun, yung simula dun sa MT, kung para sa yung MTBF and yun. So that sums up the presentation. Thank you for listening.